Hello everyone and welcome back. So continuing with Simplex 3D Noise implementation, part 2.
All right, let's go ahead and put in the code that we need to get our extra gradients, and we need to modify our lookups of our permutation table to take in our third dimension. So we'll set up another variable, call it kk, equals k masked with 255 to make sure that we don't exceed 255. Inside of here, this is looking up based off of our x component, our y component, which means we need to continue looking up for the z component. So I'm going to copy this first part and add to this our z component. So that will bring that into play. And I'll have to do this for each of these. And look up our gradient, or get our gradient lookup for our fourth point. I'll have to come back and clean some of this up. So our first GI0 is fine as is. Our second point we'll use I1, that's right. J1, that's fine. But we need to add plus K1 here, plus not equals. Okay. And then we need to look up I2, J2, and K2. And this will be plus 1 to here. So that gets us our 3 lookups, or 4 lookups actually. Now the calculations that we're going to run here are going to be slightly different as well. So we're going to be taking 0.6 minus the square of x0 minus the square of y0 minus the square of z0. This will be the same for our others. So go ahead and put that in. And our calculation part for our gradients need to be changed to vector 3s. We had our third component in. All right, so that takes care of those. And we will have to add one additional calculation. So this will be T3 oops. So So that looks like everything we need there. Now our final calculation to sum this up will change a little bit as well. So this will be 32.0f minus, or not minus, multiplied by n0 plus n1 plus n2 plus n3. This will massage the numbers into our -1 to 1 domain. Give it a build, make sure we didn't get any errors. Just give it a quick look through. Make sure that I got everything that at least I think I got everything. We'll find out real quick. So let's take this, copy this line, paste it, comment out this one. Let's add in our iterations again. I'll move this up here with our other 3D noise. I'm just cleaning some stuff up. Keep it nice and organized. Alright, no errors. Jump over into Unity. And make sure it's saved. We don't have the scene open. Open the scene. And cross my fingers and hope nothing really bad explodes. So something bad happened. We did not get it right first time round.
Oh.
Yeah, what are the odds that I actually get it right the first time round?
I'll let you have a quick glance before we do a pause, just in case you see something.
Right. Let's see, simplex noise here. All right. So all of that looks right here through here. So that seems right.
Stop.
Gonna pause it?
No, right here.
Oh, yep. Okay. So that would be one part. So that part looks right. Well, let's see what happens.
Okay, here we go.
Hey,
Hey!
that works better. But I have no idea how it's looking smoothness wise.
I mean, it appears pretty smooth. We can speed it up. I mean, it's running around 38 to 40 milliseconds.
Okay.
So if you want to jump back over into code and
Add code here.
speed it up. I also don't know what texture size we're using over in the game manager.
Should still be 128.
Okay, good.
That's our problem right there.
Yep, way too slow. Half a second.
Half second. It's like going on. Can you tell if it was lag or what was going on with it? Because sometimes the lag shows up just the same way.
Right. Ooh, very nice. Yeah, it looks great.
Okay, so that gives us our simplex 3D noise, and still incredibly fast, 38 seconds.
Awesome. Now, did you want
Or
to
38 milliseconds.
do the playing in the next video?
Well, actually, in the next video, we're going to be doing something a little bit different.
Oh, okay.
So, because we've got all of our noise, what I do want to do is compare this real quick with our other two noises. So, we were getting 38 milliseconds for that noise on our 3D simplex. I want to compare that with our 3D Perlin. At 56, 57 milliseconds. But you can see it looks a little bit different. This one looks more uniform and lower contrast.
The lower contrast is a big thing, actually.
Yep, out of the simplex.
Mm-hmm.
And then if we compare that with our revised value noise using lookups as opposed to our smoothing, When we run here, 38 milliseconds. So our value noise and our simplex is running are both running at the same speed. But if you look at them, the animation on the simplex is much
Oh, I
better.
just don't like it. That's just me. I mean, it's
Wait,
just
you don't like the motion on the simplex?
no. I'm sorry. On value, because it looks like it's just
Oh,
fading between different images, and then suddenly the whole thing just kind of slides a little. Then it,
yeah.
it's just me.
Yeah, it just doesn't look as good. But the overall look, as far as contrast between the value noise and our simplex, so if we go back into it, is pretty much the same. I
Fairly
think
close, yes.
simplex
Simplex
is
is,
probably a little bit more high contrast than our
yeah.
value noise is, but the animation is much better.
Oh, much. Absolutely.
So, but when you look at it, at least the way I look at it, I get the higher contrast noise, which we're going to be addressing as well. But we get a higher contrast noise than we get with Perlin at the speed that we get with value, but the nice animation that we got with Perlin. So it's almost like we took the best of both because the value noise, I like the higher contrast noise that we got with value, but I like the nice convection type and smooth animation we got with Perlin.
Hmm.
And I like the speed of value. But with Simplex, it's like we got the nice animation of Perlin with the nice contrast and speed of our value noise.
Hmm.
So it's kind of like the best of everything.
Right.
So, but in our next video, what we're going to do is we're going to take a look at some of the things that we can do. We've done a lot of optimization already on the value noise because we're looking at seconds when we first started. Now we're down to the speed of our simplex.
Hmm.
But we're going to look at some things that we can do that will speed it up even more, as well as a couple more tricks that we can do to speed up Perlin a little bit. And as of right now, without changing the way all of the math is done in Simplex, we've got Simplex running about as fast as we can get it to go. There is there is another trick that we will do that will speed it up a little bit, but it will only give us back a few milliseconds depending on the size of our texture. But when you're talking about something that's only running at 40 milliseconds or 38 milliseconds, if we're getting 2-3 milliseconds back out of it, you're pretty close to 10% performance increase,
Hmm.
which is pretty huge when you think about it. So every little bit that we can get out of these routines or these methods is a good thing. So
Absolutely.
we'll look at that stuff in the next video.
Okay, so that means with this, then we're
We've
done with
actually implemented all three different types of noise in both
awesome.
2D and 3D now.
Okay, fantastic. Well, with that, that is going to wrap up this video. Thanks a lot, everyone.